In this lesson, we're going to introduce sequences and series. So a sequence is a pattern of numbers that's either finite or infinite. So remember, finite means that it ends. Or stops. Infinite keeps on going. So you see in the first example, 1, 2, 3, 4, dot, 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 this would be infinite because the dot, dot, dot means that it keeps going. Also, you see that this is a sequence because it is a pattern where we add 1 each time. In the next example, we see that this is finite, which means it ends because there are only 4 terms. And you can also see it as a pattern because we are multiplying by -2 to get to the next number, which is the term. A finite sequence has a last term. An infinite sequence continues without end. So if we take a look at some of the terminology as we go into this section, first we're going to talk about terms. Terms are the numbers in each sequence. So you can see that the terms in this sequence are 2, 4, 6, 8, 10, 12. This is a finite sequence because it ends. It only has 6 terms. N stands for the number or the position that the term holds. So this is in position 1. This is in position 2, the 6 is in position 3, the 8 is in position 4, the 10 is in position 5, the 12 is in position 6. A sub n is which term in the sequence are you? So, am I in the first spot, the second spot, etc.? For example, a sub 1, when I say sub, that means that it is below. So a sub 1 is the first term. A sub n minus 1 is the previous term or the one before. So if we take a look at what we have here, it looks like we're adding 2 each time. But really, when you create a sequence, you want to base it off of the n value. So what am I doing to the 1 to get an answer of 2? What am I doing to 2 to get an answer of 4? And so on. Well, I am multiplying the n value by 2. So my rule is going to be a sub n equals 2 times n, or the number that I'm on. All right, so let's talk about writing terms of a sequence. So if I give you the pattern, I want you to tell me what the terms are. For example, I want the first term. So the first term, I'm simply going to plug a 1 in where the n is. And my first term would be 4. To get my second term, I'm going to plug a 2 in where the n is. And that term would be 3. For my third term, I'm going to plug a 3 in where the n is. And so on. For my fourth term, I'm going to plug in a 4. For my fifth term, I'm going to plug in a 5. And for my sixth term, I'm going to plug in a 6. Those would be my first 6 terms of that particular sequence. On my next pattern or sequence rule, I'm going to plug a 1 in. So when I do that, that would put it to the first power, which is 5. When I plug a 2 in, I'm going to use my 2 as my exponent. When I plug a 3 in, I'm going to use my 3 as an exponent, and 5 to the third power is 125. When I want my fourth term, I'm going to plug a 4 in, which is 5 times 5 times 5 times 5, which is 625. On my fifth term, I'm going to plug a 5 in for my exponent. And on my sixth term, I'm going to plug a 6 in. 5 times itself 6 times is 15,625. Let's practice finding some more terms. This rule is a little bit more complicated, but it's the same thing. If I want to find my first term, I'm going to plug a 1 in for the n value. 1 squared is 1, and 1 plus 5 is 6. To find my second term, I'm going to plug a 2 in. So 2 squared is 4, and 4 plus 5 is 9. For my third term, I'm going to plug a 3 in. 3 squared is 9, and 9 plus 5 is 14. For my fourth term, I'm going to plug in a 4. 4 squared is 16, plus 5 is 21. For my fifth term, I'm going to plug in a 5. 5 squared is 25. 25 plus 5 is 30. And my last one I want to find is plugging in a 6. 6 squared is 36, plus 5 is 41. So we're just substituting the number value in for the n. So in this one, it's a little bit different. My first term is 4. To find my second term, I'm going to use this rule. It says take the previous answer, which is going to be 4, and then we add 3. Each time we do it, we're going to take the previous answer and add 3. Each time we move on, we take the previous answer and we add 3. Again, I'm going to take the previous answer and add 3. Last one, I'm going to take the previous answer and add 3. That's what a sub n means. It means the previous term, or the one before. Okay, so when we took a little break. All right, so now can we practice writing rules? So let's take a look at our first example. Notice the pattern in this example is that in the top, the numerator, that the 2 is always the same. Then the bottom, remember we're going to label this as what number or position are we in? And if you take a look at the pattern, I hope that you can see that we're going by 5s each time, but this one would be 5 to the first power, 5 to the second, 5 to the third, 5 to the fourth. And so if we want the next term, we're going to have 2 in the numerator, and then we have 5 to the fifth power in the bottom, which on the previous page was 3,125. So to write our rule, we know that we want to keep the 2 the same in the numerator all the time, and then depending on what position we're in, we're going to take that and we're going to do that to the power. So 5 to that power will be the denominator. All right, so let's take a look at the next pattern. Again, we always want to base our pattern off of what position we are going to be in. So this one looks like it's adding 2, adding 3, adding 4, adding 5. That doesn't make sense because it has to be the same every time. But what I could do is say, well, what if I multiply the 1 times 2? I'd get 2, and then if I add 1, I'd get 3. What if I take the 2 times 2? And then I add 1. So basically, we're taking the number times 2, and then we are adding 1. So 5 times 2 would be 10, and we add 1, and we get 11. So the rule is going to be that I take the number of the term I'm on and I multiply by 2, and then I add 1 each time. All right, let's take a look at the next ones. So for this general rule, we see that we have numbers that are in a lot of different forms. We have fractions and whole numbers. So we should make them the same. So 3 over 2, 9 over 2, it looks like we want the denominator to be 2. So 2 3s would mean we'd have 6 over 2. 6 over 2 is 3. And if I want to get an answer of 6, I would make it 12 over 2. So the pattern, we know that the bottom is always going to be 2. On the top, we want to use that position that we're in. 1, 2, 3, 4. So what's going to happen? If I take 1 times 3, 2 times 3, 3 times 3, 4 times 3, it looks like the bottom or the top is going to be multiplied by 3. So if I'm in position 5 and I take the top times 3, I get 15, and the bottom is going to be 2. To write the rule, I say, all right, the bottom is always going to be 2, and the top, my n, is going to be multiplied by 3 each time. All right, let's take a look at the last one. So the pattern, if you remember from previous chapters, looks like the top is perfect cubes. 1 cubed, 2 cubed, 3 cubed, 4 cubed. Looks like it would be 5 cubed for the next one. And then it looks like we're adding 1 each time. So if this were in the first position, plus 1. Second position, plus 1 is 3. Third position, plus 1 is 4. Fourth position, plus 1 is 5. Fifth position, plus 1 is 6. So it looks like the next term would have a 6 in the bottom. And 5 to the third power is 125. So my rule would keep, the bottom would be adding 1 each time, and the top is actually using that special position, and I'm taking it to the third power. So this was our introduction to sequences.